Hello, everybody. Today we will be solving problem 5 of the 2021 AIME 1. The problem reads, call a 3-term strictly increasing arithmetic sequence of integers special if the sum of the squares of the 3 terms equals the product of the middle term and the square of the common difference. Find the sum of the third terms of all special sequences. All right, so we have a 3-term arithmetic sequence, and I'm gonna write it as a minus d, a, d. So a is defined as the middle term, and d is defined as the common difference. And we are given that the sum of the squares of the 3 terms is equal to the product of the middle term and the square of the common difference, which means that a minus d squared plus a squared plus, and this should be an a plus d, a plus d squared, and this is going to be equal to the middle term times the common difference, which is a times d squared. And we can expand this left side out as a squared minus 2ad plus d squared plus a squared plus a squared plus 2ad plus d squared equals a times d squared. And then we see that the 2ad terms cancel out, and then we can combine like terms, and we get 3a squared plus 2d squared equals a d squared. Or if we write everything on one side, 3a squared minus a times d squared plus 2d squared equals 0. And look what we've got here. We've got a quadratic equation with variable a. So we can solve for a using the quadratic formula. And a is going to be equal to d squared plus or minus the square root of d to the power of 4 minus 4 times 3 times 2d squared all over 6. So we can simplify that as d squared plus or minus d square root of d squared minus 24 over 6. And notice that we can only factor a d out of the square root because we are given that the arithmetic sequence is strictly increasing. And since d is the common difference, that means that d is positive, right? So we have a is equal to d squared plus or minus d root d squared minus 24 all over 6. But we are given that a is an integer, right? And for a to be an integer, a has to be a rational number, which means that this thing inside the square root, d squared minus 24, has to be a perfect square. So we can write that as d squared minus 24 equals x squared for some integer x. And then we get d squared minus x squared equals 24, which means we need to write 24 as the difference of squares. So we have 24, and we can write this as 1 times 24, 2 times 12, 3 times 8, or 4 times 6. And remember, since d plus x times d minus x equals 24 for integers d and x, we can easily just substitute these integer factors of 24 in for d plus x and d minus x, right? So we either get d equals 2, or shall I say, since d plus x should be greater than d minus x, we can assume x is positive in this case, because if x is negative, everything will work out the exact same way. So we assume d plus x is in this column and d minus x is in this column. Right. So if d plus x, or what we could do is we could say we add these two up and then we get 2d, right? So 2D could be equal to, well, 1 plus 24 is 25. It could be 2 plus 12, which is 14. It could be 3 plus 8, which is 11, or it could be 4 plus 6, which is 10. But D is a positive integer. So we can cross these out and we're left with D is either equal to 7 or 5. And in this case, in either case, X will be equal to 5 or 1 respectively, right? So in the first case where D is 7, we get A is 49 plus or minus 7 times, well, 7 squared minus 24 is 25. Square root of 25 is 5 over 6. And then in the second case, where D is 5, we get A is 25 plus or minus 5 square root of, well, 5 squared minus 24 is 1, and square root of 1 is 1. 5 times 1 over 6. So when D equals 7, A equals 49 plus or minus 35 over 6. So it's 84 over 6, or 14 over 6. And if D equals 5, A equals 30 over 6, or 20 over 6. And we can replace this 84 over 6 with a 14. And we can replace this 30 over 6 with a 5. And remember, A has to be an integer. So we can cross this case out. We can cross this solution out. We're left with the two solutions are D equals 7, A equals 14, or D equals 5, A equals 5. So our two possible sequences are 7, 14, 21. That's A minus D, A plus D. And then the other solution is 0, 5, 10. And the sum of the third terms of these two special sequences is 21 plus 10, which is 31. And so that is our final answer. Thanks for watching, and I will see you next time.